Hello and welcome to MicroCasting St. Louis's Halloween special. This is on Hurricane Sandy because Hurricane Sandy is also known as Frankenstorm because it made landfall in New York on October 31st of 2012. So today is its 5-year anniversary. So I think that this is deserving of a little bit more of a Halloween look, don't you think? I certainly think so. So here you go. Before this video does start though, this is proudly sponsored by Floyd Glass and Window. Check them out in the link below. So let's get started with Hurricane Sandy's beginning to its life. As you can see, this is it as a tropical depression 18 to be exact. Hurricane Sandy would begin expected to become a tropical storm in short order, expected to head up north and go out to sea into Bermuda's area. You can see here the satellite presentation. This is looking pretty good. You do see that central dense overcast on Tropical Depression 18. Then Tropical Depression 18 would remain a depression, actually head a little bit southward. Still expected to head up north and go out to sea with, well, something pretty unique about it happening. You can see here, this is also central dense overcast. This is going to head up north as the classic hurricane. Then Sandy would be declared a tropical storm Sandy, and would look as if it was going to head up Jamaica and Haiti, issuing tropical storm watches, and is expected to head up north into, well, the Greater Antilles. You can see here, this is it with its central dense overcast again, looking better and better, being more and more confined to a certain space as time does go on. Then you can see here is Sandy as a tropical storm, looking like it's going to become a full-fledged hurricane. Hurricane warnings now in effect for Jamaica. Hurricane watch now in effect for parts of Cuba, the Bahamas, and Haiti now also under a tropical storm watch. Tropical storm Sandy is beginning to strengthen. Then the storm would continue to strengthen rather rapidly. You can see here, this is the banding that you see, this curve banding. And then it also does have its center here. And this curve banding means that it is doing a pretty good job of developing convection, but dry air entrainment from the north is preventing this from developing further. Still, hurricane warnings now in effect for Jamaica and Cuba, tropical storm warnings in effect for Haiti and the Bahamas. Then Sandy would become what it was expected to become, a Category 1 hurricane with winds of 80 miles per hour. Now with that central dense overcast, right there you can see, and an eye even starting to develop. The 80-mile-per-hour hurricane now headed up north, expected to head into the Bahamas, Florida now under a tropical storm watch. To give you some perspective as to what's to come, here's Hurricane Sandy's wind field right now. So it's not that large, clearly, and this is headed up north, expected to strike Cuba and, well, more locations. Still would maintain winds of 80 miles per hour or so, and you can see then it would become a Category 2 hurricane on the Saffir-Simpson hurricane wind scale. Now with winds of 110 miles per hour, you can see storm expected to head up north and around. You can see it's central dense overcast still, and an eye even popping out as this thing is headed into Cuba. The storm now having tropical storm warnings extended all the way from Haiti all the way up to Florida. So this is pretty insane. You can also see here where some dry air is being entrained into the system. Here we begin Hurricane Sandy's transition. You can see it on such a large scale here. It's pretty insane. You can see here, still maintaining its intensity. The system now looking like it's going to head into New York. So this is looking like a serious concern. Still a Category 2 hurricane. Sandy would then weaken down to a tropical storm rather rapidly, and would look like this. It's becoming a much larger storm, and you can see now it's expected to head up into New York. This is a serious situation, although it is going to be a post-tropical cyclone. Tropical storm watches all the way from South Carolina to Bermuda. That is a large scale, folks. That's insane. Look at this thing's wind field now. This tropical storm has tropical storm force winds going from nearly North Carolina all the way down into the central Bahamas. That is insane. You don't see that every day. And, well, it's because this thing is making that transition from a tropical cyclone to a post-tropical cyclone. You can see here the northwestern quadrant, which is the strongest quadrant of these storms, having the most tropical storm force winds. And you can see the sheer scale of this. I mean, just again, look at this. Florida to nearly North Carolina. Sandy would then re-strengthen to a Category 1 hurricane with winds of 75 miles per hour. Look at the sheer size of this thing. This thing extends all the way from south of Jamaica, where it formed, all the way up to where it's headed in New York. I mean, this is a massive hurricane, and it's the biggest one in history, aside from Typhoon Tip. The storm is now expected to head up and make a post-tropical hurricane landfall. And let's look at this. You can see tropical storm warning in effect for North Carolina and South Carolina. Why aren't there any watches or warnings in effect for New York, Maine, those areas? The reason why is because the Hurricane Center back then didn't issue watches and warnings for post-tropical cyclones, as technically they would not, really go with the standard, but it literally is going to have the exact same impacts, and this is bad because people aren't evacuating. People aren't really getting this is a hurricane. People are thinking this is like a blizzard or something because they're having high wind warnings instead, which normally doesn't require evacuations, you just need to prepare. Continuing with Sandy's transition, you can see now massive wind field, tropical storm warnings all the way from North Carolina to Bermuda. The storm, really, you can see here just a absolutely massive system. I mean, look at this. You're seeing it from Canada to nearly down in Florida. You don't see that every day. This is one of the largest storms ever. Ever. You don't see it. Ever. This is just amazing to me. It's just amazing to me that you can have a storm like this that has tropical storm warnings all the way from North Carolina to Bermuda. And it's just nuts. I mean, look at this. Okay, getting into the wind field again. You can see the northwestern quadrant having the most tropical storm force winds, but the hurricane force winds are oddly south. You can see once again tropical storm force winds all the way from North Carolina to Bermuda. And those hurricane force winds are actually on the what's supposed to be the weakest side of a hurricane, southwestern quadrant. That's because since its inflow is no longer coming in to the northwest quadrant, but is coming into the southwest quadrant from the north, that's where those strongest winds are, because that's where the pressure gradient is highest. Alright, getting back to, the system. Now you can't really see because it's almost fully through that transition where the cyclone starts and where it ends. Basically, this goes up everywhere. This is now a part of the upper level jet stream. And you can see here Hurricane Sandy now with winds of about 80, maybe even 90 miles an hour, headed in to the New York coastline. Tropical storm warnings still in effect for North Carolina and Bermuda. This is just an insane system. Still no watches and warnings. And then you can see here it is, not post-tropical quite yet, 90 mile per hour landfall. This thing made a landfall as a tropical cyclone. So that means, listen, National Hurricane Center. Number one, you're not always right about the tropical characteristics of a cyclone. And number two, you should issue warnings anyway, even if it's not expected to be tropical. Because there should be warnings all up here, because this is still technically tropical anyway, even with your current guidelines. You can see now this is becoming part of the upper level atmosphere, getting much baroclinic support, still no watches and warnings. But yeah, you can see that baroclinic support, and I will be explaining a little bit more about how Sandy did make that transition in short order. Still though, that wind field, nuts, insane. New York getting huge hurricane force winds. And you can see Maine, all the way to South Carolina, getting tropical storm force winds from this thing. Sustained. Those aren't even gusts. Gusts extended all the way down to Florida and all the way up into Canada. This was an insane storm. I mean, you just don't see this every day. This is like the perfect storm back in the 70s that happened. It's nuts to me how this happens. Alright, let's get into Hurricane Sandy's impacts. You can see a table here of fatalities, the costliness and damage. Please pause the video if you would like to read deeper into that. Alright, let's look into the aftermath. You can see this is just an awful storm. Lots of flooding. I don't think there's much explanation to these, other than this is just bad. You can see ships being sunk. You can see roads being flooded, schools being flooded. You can see some before and after pictures comparing and contrasting these things. It's just insane to me. So now we ask, why? What could have possibly led to this? So we start with how hurricanes form. It starts with ocean water. Now, when that ocean water in the Atlantic is warm enough, It's going to cause air to rise, and we're going to have water vapor. Now, when that air does rise, that water vapor is going to turn to clouds, and here's why. Because, well, of the warmth of the ocean. So you can see, since the lower levels of the atmosphere are warmer than the upper levels, there's going to be a condensing force up there because, well, cool air is more dense than hot air. So what you're going to get is you're going to get clouds. What these clouds will do is if it condenses enough, they will produce rain. So now let's talk about what happens after this gets to a large enough scale. So we know that it takes 24 hours for the Earth to make a rotation. Well, the Coriolis effect comes in because the poles take the same amount of time to make a rotation as the equator. Which do you think has to move faster? The equator. So what'll happen is you'll naturally see that the poles move slower than the equator, and we'll see that there's going to be rotation there. And you can even see low pressure systems on both sides of the atmosphere. I mean, look at this. You have a low here and a low there, and you can see this one flowing clockwise, this one flowing counterclockwise. So, once you do have this cluster of thunderstorms, here's what you need. These are the ingredients that you're going to need. Warm Atlantic waters, you're going to need moisture, and you're going to need low wind shear. Because what's going to happen is, this is going to be, if you have wind shear, this is going to make it so these low pressure systems are not vertically stacked, which is what you want like this, but are going to be slanted like this because of the wind shear. So once you have your cluster of thunderstorms with all three ingredients, it'll become a low pressure system. If it succeeds in that, it'll become a tropical depression with minimum winds of 30 miles an hour. Now, then it'll become a tropical storm, category 1, 2, 3, 4, 5, you know the drill. And, well, here's Sandy's start. So you can see a tropical depression rotating counterclockwise. Begins to strengthen some. You have the central dense overcast. Then it becomes a tropical storm because it has winds now 40 miles an hour and is stronger, still low pressure. Sandy would head into here, become a strengthening tropical storm, become a full-blown hurricane. Now let's take a look at this. This is a category 1 hurricane. Looks like a classic hurricane. And you can see its wind field there. And this is a category 1 hurricane, with its wind field there. So same strength, but very different size. So what happened? Why did Sandy get so large? Well, it's because Hurricane Sandy's energy source shifted from the warm Atlantic waters to temperature contrasts from cold fronts. So we'll go over that transition. So let's take a look at this. This was Sandy transitioning. You have the cold front there, that's where that line of thunderstorms is. You have the cool air here and the warm air here. You have a high pressure system here, and the low being Sandy, that's drawing in all of this energy. So, let's go into, well, the beginning of this. So, it's a low pressure system, Hurricane Sandy, with equatorward outflow and central dense overcast. That means that it's getting energy in from the equator. It's getting direct energy from the warm waters below it and direct energy from heat in the equator. So during this thing's transition, here's what's going on. You have a high, and this thing is getting energy still from the warm air. You can see because of the dependency of it being a tropical cyclone, not fully connected with the jet. But then you can also see that jet bringing in thunderstorm activity as well and bringing in energy as well. That's why this thing is so large, but still has those condensed hurricane force winds. And then here it is after its full transition as it goes inland. You can see it's now part of the jet stream with it getting all of its energy from the cold. You're no longer getting energy from those warm Atlantic waters. Well, thank you so much for watching. Check me out on social media at MicroCasting on Facebook and Twitter. Thank you so much for watching. This is MicroCasting St. Louis, signing out.